Hey guys, welcome to Unit 5, Lesson 8, Complex Roots. So I want you to pause the video and try the do now on your own. The quadratic formula is given to you and try it. So it says use the quadratic formula to find the roots. Whenever we think of roots, we should remember that I'm going to set my y has to be equal to 0. Because this is the point where the graph crosses the x-axis, and those are x-intercepts, and your y-coordinate is 0. So I'm going to set it equal to 0. So I have x squared minus, I'm going to zoom in, x squared minus, what is it, 5x minus 2 is equal to 0. Right? That's why we set it equal to 0. Now we want to use the quadratic formula. Anytime you want to use the quadratic formula, everything should be set equal to 0. You cannot do it without setting it equal to 0. And remember, if you ever forget, your standard form is ax squared plus bx plus c. So what's in place of a here? It's 1. What's in place of b? Negative 5, and c is negative 2. It's always a is your coefficient of x squared, b is coefficient of x, and c is your constant. Now I'm going to write it into my formula. X equals negative. The first step, if you do substitution, is good. Try not to simplify too much. Eventually you will get into a habit of simplifying also, but I want you to be very comfortable with substitution and doing these questions before you start simplifying in the same step. It's negative 2 all over, the radical is over the whole thing, all over. And remember, the division is over the whole thing, just not this part, the discriminant. So all over 2 times 1. So now you can actually put this whole thing in the calculator itself, or two negatives make it a positive. Plus and minus, I'm going to put this whole thing, let's do that in our head. Negative 5 squared is 25, right? It's a positive number. Squaring a negative number is always positive. And this would be plus what? 4 times 2 is 8, so which is 33. So it is 5 plus and minus rad 33 over 2. So now again, 33 you cannot really simplify. There's no perfect square that it's not a perfect square, and there's no perfect square that goes into 33. So we are left with x equals, this means 5 minus rad 33 over 2. If you want to separate them, that's what the plus and minus means, right? If I wanted to graph it, my graph, I would have two numbers, like 2 x-intercepts, which would be like 5 plus rad 33 is like 10, around 10 point something, and 5 minus rad 33 would be like a negative something. Like your graph will be open up, it'll be something like this, a parabola, right? I'm not saying you should know it, but it's good to have a picture in mind. This means if you looked at the parabola, you knew you had two solutions because the graph is crossing the x-axis at 2 points. Okay, so when a parabola does not physically cross the x-axis, this means it has no real roots. So in the above question, I showed you that the graph was crossing the x-axis at 2 points, right? Whether it's open up or down, whenever it touches the x-axis, that tells you how many number of roots there are. But with complex roots, your parabolas will be like either up in the air like this or down here. Those are just a few examples. It'll never touch. Basically, they'll never ever touch your x-axis. Never. So that's what it means by no real roots. These imaginary roots may also be referred as complex roots. These complex roots will be expressed in the form of a plus bi. And we can do them two different ways. We can solve the complex roots using square root method or the quadratic formula. So just how you would solve using inverse operations. That's the square root method. Once we do it, you'll get it. So let's get started with this. What is the solution set? Anytime I say solution set, I must write my final answer in those curly brackets of x squared plus 9. So I can't really factor it because this is what you did. X squared minus 9, you could do dots, but this is plus 9. Okay? If you were to factor it, you can factor it as under complex number. It will be x plus 2y and x minus 2i equal to 0, and then set your teeth shut. I'm going to do this completely and then show it to you. What other way can you set it? X plus 2i equal to 0, x minus 2i equal to 0. So this would be what? X equals negative 2i, x equals positive 2i. But then you'll be like, I won't remember the I part or whatever. Okay, so this is for more advanced stuff. I'm not saying that you cannot do it. All I'm saying is, if you're confused with it, that's okay, because I'm going to show you an easier method now. So I'm going to rewrite this question here. X squared plus 9 equal to 0. So now move the constant over, so it'll be what? X squared equals, subtract 9 minus 9. Take the square root. So when you take the square root, remember there's a plus and minus. So the square and the square root cancel out, and you get what square root of negative 9? It is plus and minus 3i, right? Because we know, and I'll explain why. Can I rewrite it as negative 1 times 9? Separate that negative from it, right? And now what's square root of negative 1? We know it's I. What's square root of 9? 3. So that's why it's plus and minus 3i. You don't have to do that math always, guys. You can avoid that, but I wanted to show you how it's come. We've done that in the past lessons. So again, am I done with the question? No. What did I say? Your answer should be in curly brackets. So it's x equals, you can choose to write it separately or just together. So these are your complex roots. They always happen in conjugate pairs, means they'll always be plus and minus of each. Complex roots always happen in conjugate pairs. Okay, so let's do more. So find the roots of this equation. So here in the box, I want to read it. This equation is not factorable, so we apply the quadratic formula, substituting a in a, b, and c respectively. Notice we are left with a negative radicand, thus this will contain imaginary roots. So it's actually telling you what you'll be getting for the question. So I just wanted to read through it so you kind of understand and know ahead what you're expecting or anticipating from this question. Simplify the radical and write your answer in simplest form. So we already know it has complex roots, right? So what do we do? How do we do this? I'm going to find it's already set equal to 0, so that's the check. I'm going to find my a, b, and c. My a is 1, b is 4, c is 7. So now I'm going to write my quadratic formula. It's x equals negative b plus and minus b squared minus 4ac all over 2a. So you don't have to memorize it. It's given to you on a reference sheet, but it's again a good thing to know your formulas and everything. So negative 4 plus and minus b squared is what? 4 squared minus 4 times a is 1 times c is 7 all over 2 times 1. So now let's simplify this. This would be negative 4 plus and minus. Simplify the discriminant. This would be what? 16 minus 28, which is negative 12. The minute I see a negative or my discriminant is less than 0, I know my parabola is going to be somewhere up in the air. It's not going to ever touch the x-axis. Okay, so all over 2. So now let's simplify it. I'm going to simplify negative rad negative 12 on the side. You must, not only me, we all must separate the negative 1 right away. Negative 1 times 12 is a non-perfect square, right? So what's the largest perfect square that goes into 12? It's not in 6 and 2, because neither is 6 nor is 2 a perfect square. So it is actually 4 times 3, right? Because 4 is a perfect square. So what's square root of negative 1? I. What's square root of 4? 2. And rad 3 is non-perfect. So I'm going to substitute this part with 2i rad 3. So negative 4, can I write it over 2? Plus and minus 2i rad 3 over 2. What happens? The 2's cancel out, right? I'm going to rewrite it. So negative 4 divided by 2 is negative 2 plus and minus 2 divided by 2 is just 1. So I rad 3. Right? If you're writing in a plus bi form, guys, I'm going to write it here, a plus bi form. So this is your a, and I'm going to rewrite it as plus bi. Oops, it's plus bi, plus or minus bi, whatever you want to say. So I must write it as -2 plus and minus rad 3i on the outside like that. Okay, not very picky on that, but I just want you to understand that this, your b is rad 3 and a is your -2. So your solution set is -2 plus and minus rad 3i. It really doesn't matter. You won't lose points if you wrote I rad 3, but I'm just saying it, just taking that notation into consideration and writing the way it is written. Okay, now I want you to start pausing the video and try these questions on your own, so that way you understand it. I'm going to do one more. I actually want to do example 2, and then I want you to finish the rest. But before you check my solution, I want you to try it on your own and see if you get what I got, or how far can you get on your own. So it says, what is the solution to the equation this? First of all, I cannot pick my a, b, and c. So what do? I first have to set it equal to 0. Always work your quadratics. Anytime you're using your quadratic formula, it must be set equal to 0. And just in case, you should always check, are there any numbers that add to 8 and multiply to 25? Nope, there are none. So we know we have to use the quadratic formula. So it's going to be x equals, before that I'm going to write my a, b, and c. So what's my a? My a is 1, b is 8, c is 25. So I'm going to do -8 plus and minus, b square is 8 square. I'm just going to leave it like that. First is substitution, times 1 times 25 all over 2 times 1. So x is equal to -8 plus and minus, simplify the radicand. What do I get? 64 minus 100 is -36 over 2, right? So now I'm going to do this -36 on the side, which you should have been able to see it. If you don't, so it's -1 times 36, square root of -1 is I, square root of 36 is 6. So it's a perfect square, so 6i. So I'm going to rewrite it as x equals -8 over 2 plus and minus 6i over 2. Simplify it further. -8 divided by 2 is -4 plus and minus 3i. So those are your solution. You don't have to write it as a solution set because I didn't say solution set. So I'm going to leave it like that. -4 plus and minus 3i. I can choose to, or I can choose to write it separately. -4 minus 3i, comma, -4, plus 3i. So these are my solutions. So anytime, again, let's sum it up real quick. Anytime you see solutions that have I in it with the quadratics, when you're solving quadratics, it means they're complex solutions. It means they had no real roots. The graph did not touch the x-axis, and you can solve them by always by the quadratic formula. Okay, so finish up the remaining example 3, the remaining of the packet, your homework, and of course there's an exit ticket also. So please make sure you do all those 3 things, and good luck, guys.